Hello, and welcome to Udents and Clams. This is a Blender 3.4 tutorial showing how to create a rustic wooden fence. The features of this fence include cracked and split boards. Also included is a procedural texture that allows for color variation from board to board, as well as varying the texture scaling. The project started off when I was challenged myself to create these individual boards, but also divide the geometry to create a split or a check or something like that. You can see that's what we've done, is create these gridded boards and then pulled apart the geometry in various places to create that effect. I like it, and I think if you want to sell the idea of like an old barn or an old fence or something like that, having the wood distressed to this degree just really conveys that in a way that even a displacement texture really can't. Being able to see light through a fence is huge for the overall effect. Let's get into it. First things first, if you're having trouble reading the text on geometry nodes, go into YouTube settings and change the video resolution from auto to 1080p, and that usually makes things much clearer. The other thing is I will be using Node Wrangler for this, so go into Edit, Preferences, Add-ons, Node Wrangler, and make sure that's enabled. Add-ons. And it is. I'm going to create some geometry nodes. We will not need the original cube. This fence is going to be created out of a series of wooden strips, several of which will be adjacent to each other to create a board, and then several boards will be used to create the fence. So let's do that first. And I want these to be variables that are globally controlled for like the number of strips and the size of them, etc. So let's create some variables to hold those right now. So if we drag that noodle out into space, let go, and then select group input, that will create a new variable for us. And if we go to the group tab, we can see that variable and indeed change it. That will also cause it to appear over on the Modifiers tab in the inputs. And I want this to be 0.25. The other thing is we need to know the overall height of the fence, so let's do the same thing again. Drag this out into space. And we'll call that 10 meters. Hit 7 on the numpad. That's our first little strip. Progress, I say. The other thing is we want to divide this up into multiple vertices so we can affect the geometry as we go along. And I also want that the number of divisions in the Y dimension, up and down, to equal the number of strips we have. So I'll just make those the same size. And I'm going to crank the X vertices down to 2 because we do not need a split in the middle of this. So that gives us what we want. The strip is as long as we want, and each segment of the strip is more or less a square. In the future, we're going to take one edge of this and push it one direction and take another edge and push it the other. So in general, we'll have two of these things next to each other. And we'll take the right edge and we'll push it to the left. And we'll take the left edge of its neighbor and push it to the right. To do this, we need to know which edge is left and which edge is right, and this is a really convenient time to do that. If you look at this, we're going to have fence height over strip size. That's going to be the number of vertices in the Y direction, times 2, because there's a series of vertices up one side and another down the other. And I know from past experimentation that when the index is in the first half, it's the vertices on the left-hand side of the grid, and when the index is in the top half, then it's on the right side of the grid. So I'll just take all of the indices that are less than halfway through, less than this little math we did to determine the number of Y vertices, and then mark them as the left. And then anything that's not marked as left, we'll assume is right. There are a number of things that are easier if we are starting at 0, 0 on the XY plane as opposed to centered. So I'm just going to move this. And because I'm lazy and I hate to throw in a lot of math nodes, I'm going to use a bounding box to do that. So if we take the bounding box, take the minimum, negate it. So if the minimum was like 1, 1, then we'll change that to -1, -1. We'll offset that using the position, and that snaps everything to the origin regardless of where it was to begin with. The fence is going to consist of a series of strips that make a board and a series of boards that make the fence. I'm going to duplicate these strips to the number we need. And I want to do the math exactly the way I just described it. We'll create 2 new variables. And both of them integer. So one is for the number of planks that will make up our fence, and the other is the number of strips per plank. It's just easier to do the math this way for later on when we're separating the planks from each other. And that created them, but because they're all sitting on top of each other right now, we can't see that. There we go. Take the strip size, multiply it by the duplicate index, and then we'll just use that to offset the x coordinate. We're going to ignore the z for now, and the y is fine the way it is. Now we have all the strips that are going to make up our fence. Not quite happy with this though, because I also want to create some separation between the individual planks or individual boards. If we take the index of each strip, divide it by the number of strips per plank, round down to the nearest integer, multiply it by some arbitrary value to get a low number. So what this will do is every number of strips and strips per plank, we will add in just a little bit more, and that will separate the planks from each other. And I want this value, the separation value, to also be a variable. I'm going to call it plank gap and make it 0.093 meters. I think that's a nice effect. Now it's time to create the cracks. And that was the true genesis of the video, was to see if I could create a solid surface but then put splits in it. We can use a set position. And for now, we're only going to affect the left vertices of each strip. Now, what are we going to use to affect them? I've tried a few things, but the easiest and the solution that results in the fewest nodes is just do a texture. I'm going to use a Musgrave. And wherever this height exceeds a certain threshold, we will bump the edges away from it. Use 0.34. That's eventually a good value I decided on. That will decide whether we move this vertex or not. Now we just need to come up with a number to move it by. Okay, that is not useful, but it is a start. One of the things I want to do is the Musgrave has kind of a blobby texture to begin with, and I want it to be longer. I want to have the cracks be longer in the Y than they are in the X. And I could do that by changing the input here. So I'm going to take each position, keep the X and the Z alone, but dramatically contract the Y, and that gives us this effect, which is closer to what we want. Now we are obviously moving too far, so let's change that. And what I found worked really well is a power function. So take this value here and raise it to the power of some other value. And this is something else I want to put under user control. But it's not actually the crack width, but it controls it indirectly, so that's what I'm going to call it. And that is really close to the final effect we want. But we also want to move the the corresponding right-hand edges away from the same high points in the Musgrave texture. So we'll use the same greater than test. And in this case, we don't want left, we want right. So not left is right. And we will move it in exactly the opposite direction, so I can just scale it by -1. And there we go. That is pretty much it. Now I want to adjust some of these Musgrave parameters to make them a little sweeter. 5.2 for the scale, 1.15 for the detail. Yeah, and it all depends on how crazy you want these cracks to be. I determine these values by what look pleasing to me. Now the other way you could do this is start with solid pieces of wood and use Boolean subtraction to split them up. But Booleans and geometry nodes always lead to heartache. So I determined it was much better to start with a bunch of pieces, move them apart, and then once we've determined where we want the cracks to be, we could do a merge by distance to put the remaining pieces back together. Technically, this would be optional, except for the next step. Extruding this into a 3D surface will not work well unless we have done the merge by distance step. And we do not want to do individual, we want to do it as a group. And 0.33 is fine for now. Now let's give this a texture to make it a little bit more like wood. Go ahead and create a texture and assign it to and use a set material to assign it to our geometry. Go to the shader editor to give this texture some texture. We are in the wood texture. A dot, so we can get back to our nodes. I'm going to keep this really simple because the point of this is not a super convincing wood texture. I want to have something representative, but there are tons of cool procedural wood texture videos on YouTube. There's one with knots that I think is just exquisite, but it would take another half hour just to go through what that fine creator already went through. So if you're interested in a much swankier texture, look for that, but this will be pretty good for what we want to illustrate here. Let's start with a wave. See, progress already. And what makes this work, cranking the distortion up to 50, cranking the detail up to 15, turn down the detail scale to 0.5. This is pretty good, but it's very square. We want something more linear. Select a wave texture and Control-T to bring up mapping and texture coordinates. It is absolutely fine to use the generated coordinates for this. I'm going to put in a vector math node set to the scaling function so we can change this dynamically to make it look right in the next step. If we turn up the X and turn down the Y, we get this nice wood grain pattern. I also learned from looking at the edges later on that it also looks really good when you turn down the Z quite a bit. Now, in order to make this look right, let's give it some color. The color ramp turns values between 0 and 1 to colors, which is exactly what we want. I'm going to turn this black into a dark brown. And the exact value I want is 824104. And for the top value, this white, I want more of a cream color. And for that I chose Baker 1, Alpha 3, 82. Yeah, looks nice. And just to sharpen up the grain a little bit, I'm going to put one between them. I'm going to slide this over to 0.25 or so, 0.26. Good enough. and change the color to 615542. Now there's two things I want to do to make the planks distinct from each other. I want to vary the grain pattern from plank to plank, and that's easiest to do by setting the scale. Also, I want to restart the texture at each plank. I don't want the texture to be continuous across the fence. That's not natural looking, so I'll need a value to help me do that. Also, I want to vary the gamma, or the lightness of each board from board to board. They didn't all come from the same tree. They shouldn't all be the same darkness. To do that, I need values that the geometry editor is going to give me. So let's go back there. What I want to do is a storm-drained attributes that'll give me a gamma number that I can use inside the shader editor. If I just pulled a random number and stored it as a attribute named gamma, that would be stored on a per vertex basis. Actually, it'd be stored into whatever sort of domain I wanted it to be. It could be face, it could be edge, but point is the default and would generally work well, except for this, because it would generate a random value for every point. I don't want that. I don't want a random value for every edge. I don't want a random value for every face. I want one random value for an entire board. That is not directly supported in Blender, but there is a convenient workaround. And the convenient workaround is to create some geometry that we only use to hold these values. My favorite is just a point cloud. And we'll just want one of these per plank. And again, don't care what this geometry is, could be anything. We just want a series of points to store values. And to do that, we'll use a store named attribute. And I know I'm going to want a couple of these. Shift D to duplicate. The first one I'm going to call gamma. I want a random value between 0.67 and 1.42. This is conceived of to control the lightness of each board, and that's indeed what we'll use it for. But it also turns out it's really convenient for separating the textures between the boards, and also I use it to control the length of the boards. It works well for all of them. The other one I want is for the texture scaling. And we'll create a number between 5 and 50. Now what do we want to do with these? We want to copy them from this point geometry into our board geometry. That is accomplished using a sample index. And what we're going to be sampling is gamma. So what the sample index allows us to do is for every vertex on the same board, we'll come back to this same point over and over again and pull down this same gamma value for every vertex on the board. Now, what are we going to use for an index? It turns out we've already calculated that. And that value is calculated down here. So after duplicate elements, this gave a unique index to each strip. We divided that by the strips per plank and then rounded that down to the integer. This integer is unique per board. This is the value we want. And what are we going to do with this? We're going to save this back to the main geometry. And that's way everybody accessing this geometry has access to the gamma value. Later on, we're going to use this more in geometry nodes, but it also makes it available to the shader. The other thing we'll want in the shader is the scale value we set aside. Let's grab that also. Shift D to duplicate. Going to call that one scale. We'll use sample index in the same way, using the same per plank index. Grab the scale, put it in the value. The other great thing about working with geometry in this way is if I bring up the spreadsheet, we can see these values getting stored. So if you're ever curious about the exact value of one of these things you've stored, just bring up the spreadsheet and it'll tell you what it is on a per vertex basis. And it'll even show you which is the left ones and which is the right ones. Very handy. Now let's use these values inside the shader. A dot to recenter everything. So like I said, the gamma I'm using to separate the planks from each other. Bring up an attribute node, gamma, and we'll just plug it into the location. This is not a science here, but what it's doing is it's just taking this value and giving every board a unique offset within the texture, which essentially breaks up the texture patterns across the boards. But what we really designed this gamma to do is alter the color. Add a gamma node. And that will darken some of the boards and lighten others, and essentially just break up the visual look from one board to the other. And we also want to use the scale. The scale is a very potent way to make adjacent boards look different from each other by adjusting the texture scale. Duplicate this. So now you can see some boards have really exaggerated texture, other boards have a very fine-grained texture. This looks like too much, but believe me, when you render it, it's about right. I just want to finish up a couple of quick details in the geometry nodes before we leave. You know, it occurs to me that this business with creating points and assigning a meaning to them is basically a way where you can create your own domain within Blender. So I'm not just stuck with the edge, point, face domains and all the rest of them. I've created the plank domain that I can use to put values into and pull values out of. Maybe that's a useful way to look at it. And one thing I want to do is give each board a random length so they're not all squared off at the top. Accomplish that with a set position. And we're going to mess with the Y first. And we're going to use gamma once again. Now that has two problems. One, it's affecting both the top and the bottom, and I don't want to do that. Also, it's a little bit too much. So what I really want to do is instead of adjusting the offset, I want to scale. Grab the current Y. Well, now each board has a random length, but we've also dramatically increased the length of them. Let's fix that. Add a math node, change it to multiply. And I think 0.04 is right. We don't need a too exaggerated effect, just to break up the top of the fence, make it a little bit more rustic. Now, I'm reusing gamma for a lot of things. You could have as many variables as you wanted with different ranges of random values. Go nuts. The other thing I want to do is add some noise so that these rustic planks aren't so completely rectangular. Gonna grab my favorite Voronoi texture, scale it down quite a bit, 0.08. And we're going to plug this into the X. That gives us a little waviness on the side of the board, but I'm not happy with the scale. Let's turn this down to 0.36. Just want a subtle effect, nothing extreme. I also think it looks pretty good if we allow this to contribute to the Y. Just add that in. That's looking pretty good. And I'm going to call that done. This is a starting off point. It gives you the look for something. If this was a look for the fence, we'd want to put some boards, horizontal boards on the back of it to serve as braces. If it was, for example, a barn door, we'd want to make it narrower and put Z braces on it. Basically, this is a starting point for a lot of different things that are potentially in a rustic architecture. Also, I see a lot of value in the techniques for creating surfaces with cracks in the middle and at the ends. And just a general technique for being able to have random values that are on a subset of the geometry that you decide. I think these are all good techniques. The project file for this is up on Gumroad. Follow the link below if you want that. Thank you for watching. I hope you enjoyed this.